Hello, boys and girls. Good evening. How are we doing today? Everything's going well, I hope. We'll start us off with something a little funny. What do you call a can opener that doesn't work? You know, a can opener. We're trying to open up a can of something. What do you call a can opener that doesn't work? A can't opener. 7.3. Appreciate you guys that jumped on the Google Meets the other day. Hopefully that helped you guys out. The biggest problem I found with it, and there's nothing you guys can do about it, is whenever somebody popped on to ask a question, it was a question I answered, earlier, but there's nothing you can do about that. So that was okay. By the time I got, to explain it the second or third time, I really understood it. But that one, the honeycomb one, was pretty difficult. It was mostly the wording, I think, that got us. Once we understood the wording and exactly what they were looking for, that problem didn't turn out as difficult as it was. I was um, trying to actually find the sum as I was trying to find the ninth ring, as opposed to just finding the ninth ring. Anyway, that's neither here nor there. I want to talk about 7.3 today, guys. It's the next one. We did series and sequences, or sequence and series. Then we did arithmetic, where it had a common difference between the two terms, or between all the terms, not just the two, between all the terms. And now we're going to do geometric. Okay, 7.3 is geometric sequences and series. Again, sequences are just common between them, like these guys down here. A series will have a plus sign between each one of them. And so that's the only difference between a sequence and a series. And sometimes I'll interchange them, and I probably shouldn't, but sometimes I will. So this is going to be geometric. And guys, here's the difference between it. Look at right here, right? 4 to 10, 10 to 18, and 18 to 28. 625 to 125, 125 to 25, 25 to 5. A geometric is a ratio of common terms. So it has a ratio of a common term. In other words, it's just a multiple. Okay? You got to multiply 4 by something to get 10. You got to multiply 10 by something to get 18. 18 by something to get 28. And it's the same value. And so the easiest way to do it is just to divide it, find the divisor. So I'll just go 10 over 4, or I'll go 18 over 10, or I'll go 28 over 18, or I'll go 40 over 28. Any one of those is going to give it to me, but it has to be common. So if one of those is different, it's not a geometric sequence. All right. I'll put 125 over 625. I'll put 25 over 125. And each one of those is going to give me that value. Okay. So common ratio is the difference between geometric and arithmetic. Arithmetic. 1, 2, 3, 4. Geometric. You just got to think of multiplication with that, or ratios. All right. So example number 1. Decide whether it's geometric. Is it geometric? Find the ratio. So they put 10 over 4. They put 18 over 10. They put 28 over 18. And they put 40 over 28. This was 10 over 7. This was 19 over 9. Immediately, that's no longer geometric. Okay, as soon as one of them's different, it's no longer. So I didn't have to do all of them, guys. I could have put 10 over 4 and got 5 over 2, 18 over 10 and got 9 over 5. Boom, done. It's not geometric. Okay, 125 over 625 is 1/5. 25 over 125 is 1/5. 5 over 25 is 1/5, and then of course 1 over 5 is 1/5. And so that one is geometric, with 1/5 being that common ratio. And that's going to be our goal for that, is to find that common ratio. Okay. All right. Got to practice telling me if it's geometric or not. I'm not going to go over that. That's pretty simple. Okay. Rule for a geometric series. Okay. There's 2 rules for this, or 2 rules we're going to use. One's going to be a rule, and then one's going to be the summation. Same type of deal. So the nth term of a geometric sequence is a sub n, a sub 1 times r to the n minus 1. And let me flip that over right here. I like to put a time sign right there, or a little dot right there. that keeps me from trying to multiply that together. And that also, if it's 2 times 3 and you don't put that dot or you don't put parentheses, it looks like 23. And so you want to put some type of parentheses or do something that we can separate that first term from that ratio. Of course, a sub 1 is that. It's just the first term. R is that common ratio. And then n is that nth term, whatever we're looking for. So this n and this n. So if I want the 8th term, then that's going to be a sub 8. I'll put the first term, I'll put the ratio, and then I'll put 8 minus 1. Okay? So it's a pretty simple formula. It's not that bad. It does end up being exponential because of the ratios. And that's why that n minus 1 is an exponent up there. All right, so let's go down here to my example number 2. Write a rule for the nth term. Okay, now I know why I put me up here. There. Letter A, example number 2. For 20, 100, 500. And then I'll go ahead and just do B up here at the same time. B is 152, negative 76, 38, negative 19. Okay, write a rule for it. So I'm just going to go right up here, guys, and plug and chug. Boom, plug and chug. A sub n. A sub 1 is 4. R, I got to figure out what the ratio is. 20 over 4 is 5. 100 over 20 is 5. So it's 5. Pretty much knew it was going to be geometric. Now, later on, you're not going to know if it's geometric or not. That's funny. That looks blue, but it's black. I got a different pen this time. I can't find my pen. And then I'm just going to do n minus 1. And that's it. Okay, that's pretty easy. Over here, we'll go a sub n equals a sub 1, 152, parentheses. I got to do my ratio. Now, this one's a little bit different because it is a negative. And I got to do 76 over 152. I think that's 1/2. It's going to be negative 1/2. 38 over 76, 1/2. 8 times 2. So this times 2 gives me 19 times. So it's going to be negative 1/2 to the n minus 1. Okay? Now recognize that, right? If n happens to be 6, 6 minus 1 is 5, it's going to be odd. Okay? Because the first term is positive, the second term is negative, the third term is positive, the fourth is negative. 4 minus 1 is 3. That's going to give me a negative. So that seems to work right there. Okay? So those shouldn't be very difficult at all. There's the answer to the first one there. They put those parentheses around there. I kind of like that a little bit better than that multiplication symbol. And then here's the second one. 152, negative 1/2, n minus 1. And now I'm supposed to find the 7th term. Well, to find the 7th term, you just plug in 7 and plug and chug, and you probably need a calculator for that. Okay, so get you a calculator for that. That's fine. All right. Okay, write a rule for the given common. Okay, so now we're going to go a little bit more difficult here. Example number 3. And write a rule. A sub 4 is 12, and R equals 2. And A, they tell me to write the rule, and then B, they tell me to graph it. And again, guys, I'm not going to want you to graph these things. I don't have any reason at all. Just understand that, again, if they do ask you to graph it, it's a sequence. It's not continuous. It's not, so we should not connect those. It should be more of a scatter plot type thing. Okay. All right, let's flip that over here. Well, I got this rule right up here, so I'm just going to plug and chug into that right now. Let's see if I can. I gotta know what a sub 1 is. So I bet I got enough information to solve that. I know that a sub 4 is 12. So this is going to be a sub 4 equals a sub 1, r, which is 2, and then 4 minus 1. And then if a sub 4 is 12, then that's going to be 12. Because it told me a sub 4 equals 12, so I'm going to put 12 right there instead. And so this ends up being the third, and 2 to the third is 8, and I'll need to divide both sides by 8. And I'll reduce that. That will become 3/4 equals a sub 1. And so that rule should simply be a sub n is a sub 1, which is 3/4 parentheses 2 to the n minus 1. I almost cut that off, you guys. All right, let's go back over here and see how we did. Go through there. They put 1.5. Uh-oh, 1.5. Oh, my goodness gracious. Good thing I checked that. 12 divided by 8 is not 3/4. It's 4/3. Knucklehead. That's not a chop your head off move. That's just being silly. So let's write it correctly. 4/3. I bet there's some people in there saying, what the heck? How'd that happen? Divide it by 8. I got it written right there. Knucklehead. Good thing I checked it. And then, like I say, there's a graph, and you can look and see it's exponential. Okay? So when you multiply by that term right there, it ends up being exponential. Something kind of interesting. All right. Example 4. A sub 3. So the third term is negative 48. A sub 6 is, holy cow, 3072. Find the rule for the nth term. All right, find a rule for the nth term. Now, you guys probably figured this out a little bit better. If this is the third term and it's negative 48, and this is the sixth term, which is 3072, we've got to figure out the common ratio to get there. So I think what I'm going to do is I'm just going to plug and chug back up into my formula there. And I know that I will have negative 48, because that's a sub n, is equal to a sub 1, because I don't know what a sub 1, and I don't know what r is. R to the 3 minus 1, which is squared. Okay? And then over here, I'm going to say 3072 equals a sub 1, r to the 6 minus 1, which is 5. Okay? Now, the easiest thing is to probably solve for is A1. Solve it for A1. And you can solve this one for A1 or solve this one for A1. But if you solve it for R, you got to start doing some roots. You either have to do the square root or you have to do the fifth root. It's going to start getting a little bit nastier. Solve it for A1. R squared. R squared. Now I'm going to put this in place of that. And so I have 3072 equals, instead of A1, I have negative 48 over R squared times R to the fifth. And then if you guys can remember, right, we have 5 R's on top and 2 R's on bottom. So 2 of those, we're going to get 2 of those. Leave me with 3 of those. Let's divide it by negative 48. And let's see, 4, 7, 6, 5. I got a calculator. Let's do it. That'll make me put that out. Don't save it. 3072 divided by 48, 64. So 64 negative equals r cubed. Now I got to root that thing. -4. Okay. Oh, almost hit that up. Sorry, guys. -4. I'll take the cube root of that. Now I'm going to plug this in either here or here. It's probably easier right here to figure out what a sub 1 is. So r squared ends up being 16. -48 over 16 equals a sub 1. And that actually is -3. And now we have a sub 1. And we have r. And that's what I need for my formula. A sub n equals -3, -4 to the n minus 1. No, do not multiply that and make it positive. Right? That's multiplying before you do the exponents. Chop your head off. The difference between this one and the previous one is the previous one. No, I'm sorry. That was this one way up here. That was not previous. That was this one up here. It went positive, negative, positive, negative. This one's going to go negative, positive, negative, positive. That's what it's going to do. Yeah, I got that one right. Guided practice. Okay. Here's where they're showing the formula for series. This actually proves it. You don't care. You want the formula right there. Okay. S sub n. Anytime you see the S, that's the sum. Equals a sub 1. 1 minus r to the n over 1 minus r. And all that's in parentheses. Okay. Let's lift that up a little bit. Don't be a knucklehead and cancel those things out. That is by far one of the biggest chop your head off things you can ever do. Don't cancel the ones. Don't cancel the r's. You can't do anything. So that's it. So you'll either have to find r, you'll have to find a sub 1. You may have to find both. They may give you both. Right? So let's go ahead and do an example. Let me turn the page because I'm out of paper. I haven't used this much paper since college. I'm starting to have to use the backs. All right. Find the sum. Okay. And they use the summation sign. So we'll use it too. I use n. I like n better. I's just mess me up. I's, that's the square root of -1. And I don't know. Okay. So my formula is S sub n is equal to a sub 1, 1 minus r to the n over 1 minus r. And so I need to find three things. I need to find a sub 1, I need to find r, and I need to find n. Well, to find a sub 1, I'm just going to plug in 1 into my formula. 1 minus 1 is 0. 3 to the 0 is 1. 3 times 4 is 4. So and I'm just going to go ahead. R is going, well, that's R because it's in the form. Heck, I didn't even need to do all that because, well, that's kind of tricky though. This is a sub 1 and that's your R though. So there's your R. 3. And how many terms are there? Well, there's 16 terms. This is telling me. This gets a little tricky if that's not a 1. If that's not a 1 there, we got to plug and chug to figure out what the first term is. Be careful about that. That's a tricky gotcha. Okay. 16 over 1 minus 3. All right. And from here, I just plug and chug, start going to town. Let's see if my calculator is smart enough to handle this. Turn it on. And I'll just do 4 times parentheses 1 minus 3 to the 16th power. I need to put that in parentheses because I want to divide that by, well, I can just say -2. Woo! Big number. 860934440. There it is. There's a word problem using it in real life. I hope y'all like my hat. I brought my old school hat out. That's my lake hat. I gotta wear a hat because my hair is just god awful. And then we're gonna have our homework, guys. I'll do another Google Meets tomorrow from 2 to 3. If anybody needs some help, did I do it from 2 to 3 or 1 to 2? I think I went 2 to 3 because somebody requested me to get on there at 2:30, so I did 2 to 3. Hey, but if you get to working and you're working and it's a little bit earlier, send me a little email. Typically, I'm just sitting here watching TV or doing something like that. I did grade your Chapter 5 exams. I put those in. I got to grade your PIOT exams, and that's all I got to grade. I'm done. Everything I've done, I've caught up with. By the time you are watching this, probably, unless you're watching it late tonight, but by the time you're watching this, I will have already graded your 7.2s. And so your 7.1s are done, your 7.2s will be done. I'm doing pretty good by finally catching up with all this stuff and getting caught up on my grading and kind of getting a routine down. It kind of makes my eyes look weird. But I can't see that and look at you. So, all right, whatever. I'll give you the work. I'll give you everything else. I hope everything's going good with you guys. It's tough doing it like this. We're doing okay. We're getting through the lessons, but I just miss seeing you guys. I can't see your faces to see how you understand it. I really appreciate you guys that jumped on the Google Meet the other day. It was good to see. I had probably been my record number of kids that were on there, and it was real good to see you guys and intercollaborate and just talk about. I mean, we didn't even talk that much about math. We did a little bit there, but we just got to catch up on you guys. I told some of them some bad news and some good news. So I don't know. It's bad news. Depends on how you want to look at it. It was the same. It was the same information. It was the same thing as good news and bad news, but depends on how you want to look at it. I'm done talking for tonight, guys. I'll upload this and get to work. Love y'all. Miss you. Hope everything's good. Stop.